Hello, I am Vaishali. Welcome you all to my channel. So today I am discussing a new topic with you in the complex analysis. In the previous video of complex analysis, we have already discussed analytic function. Then analytic function, we discussed a CR equation in Cartesian form. Okay. Then after that, I have discussed with you CR equation in polar form and how to prove the function is an analytic function. Okay, and what are the conditions required for a function to be an analytic function, and we have done 3-4 questions depending on these topics, CR equation Cartesian form and CR equation in polar form and analyticity of a function. After that, we discussed the harmonic function, that why we say a function is harmonic and what is the condition necessary to show when a function is harmonic, and we done 3 to 4 questions based on this topic. Today I will discuss with you a Milne Thomson method. Okay, and inside this Milne Thomson method topic, I will discuss with you what is the derivation for Milne Thomson method and how we obtain two formulas. The formula which is based on u, when the u is given to you, how you can obtain fz. When v is given to you, how you can obtain a function value fz, how you can obtain the value of a function fz by the help of Milne Thomson method. This we discuss today in this video. Okay, so before going to the derivation of Milne Thomson method, I just want to make you a request. If you feel my videos are helping you, so share with your classmates so that they will also get benefited by it. And secondly, if you have any query, please post your comment in a comment section below and subscribe to my channel. Okay, this only I want from your side. So now start with the Milne Thomson method. Why we use Milne Thomson method? What is the benefit of reading the Milne Thomson method? You should know it. What is the motivation behind Milne Thomson method? Actually, what happen if we have the value, if we have a value of u or the v functions and we want to obtain the value of a function fz in terms of z, then we use the Milne Thomson method. Okay, inside the Milne Thomson method we have two formulas how we can obtain the value of fz. Okay, so now starting from here, we know that this, I think everyone knows that z can be represented in the terms of x and iy. We write it like this, z is equals to x plus iy, and a function fz can be represented as u plus iv, where we know u represent the real part and v represent the imaginary part, and u is the function of xy and v is the function of xy. So we write it like this. We have fz is equals to u, which is a function of xy, plus iv, which is a function of xy, and z, which is equals to x plus I. Okay, till here I hope it is clear. Now we know that z is equals to x plus iy. If I want to take the conjugate of z, which is equals to z bar, then it will be represented as x minus iy. If we add these two, means if I want to find z plus z plus conjugate of z, and if I want to find z minus conjugate of z, I get the values in terms of 2x and I get the value in terms of 2iy. Okay, so by the help of this I can find x and y. X is equals to z plus conjugate of z by 2. I can write it like this. Similarly, z minus conjugate of z upon 2i is equals to y. So here they have written the same thing. X is equals to 1 by 2 x plus z bar. Y is equals to 1 upon 2i z minus conjugate of z. So putting these values of x and y in this equation number 1. So fz is equals to u inside the value of x and y. Similarly, iy inside the value x and iy. Now replacing z by z bar. If we replace z by z bar, what we'll get here? We'll get 2z divided by 2. We'll get z. Okay. Similarly, what we'll get 0 here. So u bracket z comma 0 plus iv bracket z comma 0. So this is the value of fz. Now after obtaining this value of fz, I want to find the value of derivative of fz, which is equals to f dash z. F dash z can be represented as del f upon del x, because z is a function of x and y, so we derivate it with respect of x partially. So del f upon del x. Del f upon del x can be splitted as del u upon del x plus iv del v upon del x. Now it is in terms of u and v. I want to change it this full in terms of u. So I want to use CR, Cauchy-Riemann equation. So we have two Cauchy-Riemann equation. First Cauchy-Riemann equation is first Cauchy-Riemann equation is del u upon del x is equals to del v upon del y. Second is del u upon del y is equals to minus times of del v upon del x. Now this del v upon del x can be changed to minus del u upon del y. So it will become del u upon del x minus I del v upon del u upon del y. I hope this is clear. And we know del u upon del x can be represented in a short notation as u with a subscript x, and we assume that ux is equals to phi 1 xy. We just assumed it. Okay. Similarly, del u upon del y can be represented as u with a subscript y, and it can be assumed as phi 2 x comma y. I hope this too is clear. Now putting these value here, what we'll get? Phi 1 x comma y minus I phi 2 x comma y. So f dash value is, if I replace x by z and y by 0, I'll get the value of f dash z as phi 1 z comma 0 minus I phi 2 z comma 0. So this is the derivative of a function. As we have to find fz, so we have to integrate LHS and RHS. When we integrate it, we get fz, which is equals to integration of phi 1 z comma 0 minus I phi 2 z comma 0 dz plus a constant c. This is clear. This line is clear. If this line is clear, this is the formula for the fz. This is the formula for the fz when u is given to you. When u is given to you, then you have to find phi 1, phi 2 and put the value of fz is equals to integration of phi 1 plus minus I phi 2 plus a constant c. This you have to do when u is given to you. Directly you can find the value of fz by the help of phi 1 and phi 2. Okay. Now you can ask me the another question, ma'am, if u is not given to us, if v is given to us, what we'll do, how we'll find? If v is given to us, then we'll change the formula with respect of psi. We'll do that formula with respect of psi. If v is given to you, then the formula will become this. Okay, how? I'll tell you. See, from this step, f dash z is equals to del f upon del x, del u upon del x plus I del v upon del x. Del v upon del x should remain the same. Del u upon del x is equals to del v upon del y. So it will become del v upon del y plus I del v upon del x. Okay. So after this we get this formula. The formula will become, I'll tell you, del u upon del v upon del x is represented by psi 2 z0, and del v upon del y is represented by psi 1 z0, or you can say it like psi 2 xy, where x goes to z and y goes to 0, which is equals to psi 1 x comma 0, x goes to z and y goes to 0. Is this clear? We write it like this. Now after writing this, we put it in the formula fz is equals to integration psi 1 z comma 0 plus I psi 2 z comma 0 dz plus a constant c. So you can take the help of these and then you can get the value of fz. Okay, so we got two formula. First formula of fz with when u is given, second formula of fz when v is given. Now we are using these two formulas to, here we have a question number 1. Listen carefully what it is given and how we have to solve that. I'll explain you. If u is equals to x minus y square, so u is given to us, which is the value is x square minus y square. Find a corresponding analytic function. That means we have to find the value of fz. So if you get such type of question, just a Milne Thomson should strike your mind and you should write the formula, and we will use the first formula because u is given. So fz is equals to integration of phi 1 z comma 0 plus I minus I integration phi 2 z comma 0 dz plus a constant c. Will use this, and we know phi 1 xy is equals to ux is equals to del u upon del x. We know this, है ना? And we can also write it like this: phi 1 z0, x replaces z and y replaces 0. So we want this to be solved, del u upon del x. U is this, 2x square minus y square. What is del u upon del x? Differentiating this first. I just name it as first. Differentiating first with respect of x. So we get del u upon del x, which is equals to 2x. Okay. So phi 1 z0 will become 2z. Okay, because y is not there, so I put x as z, so it will become phi 1 z0. Similarly, phi 2 z0 is equals to del u upon del y. So differentiating first with respect of y, so we get minus 2y. Now y is 0, so putting here 0, we get phi 2 value as 0. Now put it in the formula. Fz is equals to integration of 2z dz plus a constant c. So it will become 2z square by 2 plus a constant c. It will become z square plus c is the answer. So fz can be represented as z square plus a constant c. So this is your answer. Okay, so this is the analytic function fz. So I hope this question is clear to you. Now moving to the question number 2. Now we'll discuss the question number 2. Now first I read the question so that I can explain you. If you feel, see, these videos are helping you, so please subscribe to my channel. And share your feedback in the comment section below, which really motivates me to make more videos for you. Okay, now moving to the question number 2. What it is given? Show that this e to the power x cos y minus y sin y is a harmonic function. We have to show that this given function is a harmonic function. If the analytic function for which this the above given value is imaginary part. He says there exists a function f which is analytic in nature, which can be represented by the real and the imaginary part, and the imaginary part of the function is given by this value. Okay, so it means this is the value of v, and we have to show, first part we have to show v is harmonic. Okay, so for that, to show v is a harmonic function, if you have seen my previous videos, then for that we have to satisfy the Laplace equation. Okay, so that means we have to show del 2v upon del x square plus del 2v upon del y square is equals to 0. So that means if I termed it as 1, we have to differentiate first with respect of x 2 times, with respect of y 2 times, and we have to add it, and then we have to see whether we are getting 0 to right hand side or not. Okay, I am start doing it. Del v upon del x is equals to e to the power x cos y minus y sin y plus e to the power x cos y. Now differentiating it again, del v upon del x square is equals to e to the power x cos y minus y sin y plus e to the power x cos y plus e to the power x cos y. So it can be written as e to the power x cos y minus y sin y plus 2 e to the power x cos y. Okay, now we have to find the value of del v upon del y. Okay, so del v upon del y. Now I am differentiating first with respect of y partially. So e to the power x cos y का क्या होगा, sin y. I'll write cos y as sin y minus, so here as 2 terms of y I have to differentiate it 2 times. So first y, sin is converted to cos y, minus y differentiating partially it is 1, then it is sin y. Okay, now del 2v upon del y square e to the power x sin y is converted to cos y minus y so I put it 1 inside the bracket, 1, then cos y plus y cos to minus sin y, and minus sin is converted to cos y. Okay, so it will become e to the power x cos y minus 2 cos y plus y sin y. It is minus plus sin y. Now this is the equation number 2, and I just changed equation number 3. Now adding 2 and 3. If we add 2 and 3, we'll get del 2v upon del x square plus del 2v upon del y square equals to 0. So first part is satisfied, that we have shown that the function is harmonic. Now we have to find the value of fz when v is given. So we'll use second formula of Milne Thomson method. See, v is given to us as e to the power x cos y minus y sin y. We have to find value of fz. We have to find the value of fz. Okay, and for this we'll be using the formula fz is equals to integration psi1 z0 plus I psi2 z0 dz plus a constant c, where we know psi1 xy is equals to del v upon del y, which is equals to, now differentiating 1 with respect of y, differentiating 1 with respect of y, we get e to the power x, x cos y converted to sin y, minus 1 sin y plus y cos y okay. Now it will become e to the power x, x cos y is converted to sin y with a minus sign, minus y is converted to 1, sin y will be as such, and plus y, okay, sin y square minus sin y, so this is your final. So it will become e to the power x minus x sin y minus sin y minus y cos y. Okay, so this is your psi 1 xy. Okay, this is your psi 1 xy. Now what is the value of psi 1 z comma 0? Putting x as z and y as 0. If you put y 0, so sin y 0, sin y 0, and here y 0, so this is 0, so psi 1 is yours 0. Now you have to find the value of psi 2. Okay, you have to find the value of psi 2. Psi 2 xy is equals to del v upon del x. Now differentiating 1 with respect of x. So it will become e to the power x, then x cos y minus y sin y, bracket close, plus e to the power as such, x will be 1, then it will be cos y, and the remaining is of y is 0 because partial differentiation we are doing. So psi 2 z comma 0, putting y as 0, y is 0, sin 0 is 1, cos 0 is 1, so I'll directly writing it e to the power x, it will become z, cos 0 is 1, okay, minus, then 0, e to the power x, then 1, so it will become 1. So e to the power x 1 plus z is equals to psi 2 z0. Now putting these values in your formula 1 dash. So what it will become? Fz is equals to integration of psi 2 is 0 plus I integration of e to the power z put it as z. So e to the power z 1 plus z dz plus a constant c. So it will become e to the power z 1 plus z plus integration of, wait, I just write it here. In last I'll got fz is equals to integration of e to the power z 1 plus z, okay, with I and dz plus a constant c. Now I'll solve it. I e to the power z plus z e to the power z dz plus a constant c. Now I integration of e to the power z will be e to the power z. When I'll solve this z e to the power z, I'll get the value as z e to the power z minus e to the power z, okay, plus a constant c. This and this will be cancelled, so I get fz as I z e to the power z plus a constant c. So this is your final answer of the above question. I hope this question is clear to you. Okay, now moving to this question number 3. In this question, see, this is totally different question and quite lengthy question. I'll tell you only the procedure, and the remaining you solve yourself by using the concept of question number 1 and question number 2. See, it is given if u plus v is such a big value 2 sin 2x upon e to the power 2y plus e to the power minus 2y minus 2 cos 2x. We have the value of u plus v. We have to find the value of fz. So we only know if u is given to us, v is given to us, then we can find the value of fz. So what is the process? I'll just explain. You see, for that question, we will do these steps. Fz is equals to iv. Now fz is equals to iu minus v. Adding 1 and 2, 1 and 2, adding 1 and 2, we'll get fz 1 plus i. fz1 plus i, which is equals to u minus v, separating real and imaginary part, plus I u plus v. Now I assume small fz1 plus I as capital Fz, okay, and u minus v as capital U and u plus v as a capital V. So I can write capital Fz is equals to capital U plus capital V. So we get the value of u as u plus v, which is equals to this full value. It means this is the value of v, and we have to apply, for finding the value of fz, we have to apply the formula psi1 z comma 0 plus I psi2 z comma 0 dz plus a constant c. If you apply this formula, okay, and then you put the value of psi1 and psi2, you get the value of function. And this formula I already told you in the previous 2 questions. I hope this you can do yourself. If you have any query, then you can ask me in a comment section below. Till then, goodbye and take care, and thanks for watching my videos.